Hey guys, welcome back to the shop. So we have a pile of aluminum and steel there on the table that needs some machine work. It's going to be a pretty good size project. We're going to be using the American Pacemaker Lathe and also the Flex CNC to get this project done. So let me pull you in here a little tighter and show you what we got and what we have to make. All right, so here's our stack of aluminum disc right here. These are 1-inch thick. Joe over at the welding shop burned these out, and this is what we're making right here. And what we're calling this is what the customer called it, a beauty ring. And it's just it's a very simple trim ring is what it is for some light fixtures. And that's really all I can tell you. We can't really discuss where it's going or who it's for or anything like that. But what we're focused on is turning this right here into something that looks just like that right there, okay? So the cool thing about this part is because of what it's used for, the dimensions on this are pretty loose. The main thing that we want to do is make sure our counterbore is correct, our hole pattern is correct, and we have some nice finishes on this too, okay? If we're off on our diameters a little bit, it's really no big deal. What was explained to me is that there's some type of light fixture that actually bolts into this, and they even said they only use 2 of the holes to bolt it in there. They don't even use all 6, but maybe that's so that they can index it if they need to. I'm not really sure, but it's going to be a trim ring is all it is, and it actually sits down on the ground too. So it's supposed to make an area look nicer where these lights are going to be sitting on the ground. All right, so they requested to have 8 of these made, and that's what we have right here. We have some 6061 aluminum, as I said, burned out of, or plasma cut out of 1-inch thick. So this was something that we were kind of struggling with at first, is to find somebody that could cut these guys out. We thought that the the regular steel suppliers that we use would be able to handle this, but we really struggled finding somebody. And then we had somebody locally that have a water jet price is cutting these out, and you would not believe the astronomical price to cut these things out on a water jet machine. It really just kind of blew our minds of how expensive it was. Even supplying the material, it was going to be absolutely ridiculous. But I don't know much about water jet, and apparently these things take a long time to cut, especially with the 1-inch stick. So Joe did a test. He took 2 pieces of 1/2-inch aluminum, tacked them together, and he plasma cut it on his machine, and it worked. Now, it's not the prettiest cut, but we don't care about that because we're going to be machining the OD, we're going to be machining the ID, we're going to face them all. You're not going to see that, but we got the job done, and here we are. So my plan of attack is to take these to the American Pacemaker. We'll chuck them on the ID. We're going to face one side, and we're going to turn the OD to size. I'll be able to put some chamfers on the OD. That is going to finish the OD and the back side. From there, it's going to go to the Flex CNC, where I'm going to have 2 separate fixtures machined, and we have this guy here, and then we have this guy right here. The square piece, this is 1-inch thick steel. We're going to have to machine these fixtures here, so that's probably going to be a video in itself, getting those guys done. But once we get the lathe work done on the OD, I'm going to have this guy machined with a counterbore that the ring can just sit down in, and that's what's going to center it up. We'll have some clamps on the outside of it. We'll have it clamped out here in 4 places, and then we can come in here and machine this ID with our milling tools, put the hole pattern in there, and that'll complete this ID part of it. Once it's through on this fixture, we're going to have this round fixture right here. This is one that we pretty much already finished up. We have a separate video on this, but we'll remove it from this fixture, set it on here. There's going to be a register machined on that. We'll probably do this in the Pacemaker also. And then this ring, we'll go from that one to this. Clamp on the inside, and that's what this clamping ring is for right here. I am going to face that off so that it is flat on one side, but this will just sit down in there, and I can't get it to spin, but there you go. So it'll line up with those holes, and then we can just simply bolt it to this. And my plan of attack is to mill this outside bevel. You can see it's tapered. So I'm going to get me some good quality ball mills. I'm trying to figure out the best one to use. I have a little bit of time, so I'm going to get those ordered very soon. And we will just use a ball mill to machine that outside. And I'm just really hoping that I can pull this off. Now, this was obviously a lathe part. This one was done on a lathe. You can see the turning steps in there, you know, the tool marks, you can see that. But I'm hoping that we can pull this off by just letting the Flex CNC come in here and ball mill that taper and finish that out. So that's my plan anyway. So I think it's time to just go ahead and get started on it. As I said, we'll probably have a few videos. We'll start off with the American Pacemaker, getting this lathe work done. Once we have this part of it done, we'll move on to our fixtures and start working on those. All right, we're over here on the Pacemaker lathe. I've already got our forward jaw adjusted to where we can slip our rings up here. We're going to chuck it on the ID using this part of the chuck jaws there, and we'll bump it up against this face. But I am going to run an indicator on there and just try to make sure that the back face that we're going to be facing off is nice and true. All we want to do is just clean it up. So this inside is burned out, plasma cut 7 inches. It's going to finish at 7 7/8, so we should have plenty of material to clean up there. And I just want to put this part in between the two jaws, not like that. Get it pretty close. One of the things you got to remember when you're chucking the ID like this is that you're actually touching on the two corners of each one of the jaws. So if you have a lot of movement that you got to do, you got to make sure you're not over tightening these things so that you have enough room for it to kind of move around and center up as you're indicating. I just want to look at see if the plate's touching all 4 of the faces there on the jaws, and it looks like it is. That's pretty good right there where it's at. Make sure it's snug. These edges are pretty sharp. That's why I'm using these gloves here. I'm not worried about deburring it because we're just gonna turn that off. All right. So to indicate this, there's obviously a few ways you can go about doing this, but this is such a rough edge right there, and it's not consistent. So you can see that the kerf actually kind of does like this as you rotate it. You got some high spots and some low spots, but the top side, which is the back side here, which is where the plasma torch was cutting from, looks pretty darn consistent all the way around. So we're going to indicate on the back end right there, and to do that, we're going to use a surface gauge instead of a dial indicator. We're going to use our Starrett number 257 surface gauge and the scriber. I'm using the bent end of the scriber there. And we're also going to be utilizing the 2 pins right here. So we've got those pushed down. And we will set it right here on this part of the carriage. And the pins will just kind of keep it in place like that right there. But we can kind of move this as we need to. I'll get you in closer. I'll try to get some close-up shots of this so that you can see what's going on. But let's go over the overall shot so you can see what we're doing right here first. Sounds like we got some thunderstorms coming in. So yeah, I'm gonna take that bent pointer right there. It's really all it is, a pointer that we're gonna be using this for. And we're gonna get it right up close to the diameter there. Okay, you can hear it. So it's surface gauge is I consider it also an audible tool as well. So you're looking to see the movement on the OD against that point, but you also can hear it too, indicating where it's touching. So obviously where it's touching is your high, right about there. So I'm going to say this jaw here is high, and when you rotate it 180, it's a little bit lower on that one right there. We want to try to just get an average if we can. This jaw's touching right here too, so it's not off much. I'm going to say it's less than 1/8 of an inch off total. Just trying to find my high again. It's going to be that one right there, so just come in and touch it. So that one right there. So what we're going to do is loosen that one lightly, and we don't have this very tight yet, and we're going to go ahead and rotate it 180 and pull this side back. Pivot the scriber in. 180. This side's touching here. All right. Loosen that one. Bring it around. Pull this one back a little bit, and we're just going to continue to do that until we can kind of get an average of where this thing is high and low at. That's going to be your low. It's already pretty close there. What we have is like sort of an elliptical shape. So two sides of it are a little further apart, and then the other two sides are a little closer together. That one's a little bit further out. We have it pretty close. This is probably going to be well within our range that we need to be in for turning this OD down. I've got the OD running about where I want to. I think it's very close. It's probably within, I'd say probably within 50 thousandths of being true on the OD. So we're going to go ahead and check our OD now. See where it's running at. We'll just go ahead and we'll just stick it out here somewhere and see what it's doing. All right, so this side's a little low, a little bit high. Then we're going to go to the other jaws and look at that. So -4. That's pretty close on those two right there. So we definitely have a high spot on this one. Just going to give it a few bumps and see what happens. Zero, about 15. So I'm bumping in line where it's going to be touching the jaw, which it actually, yep, it looks like it's off just a little bit. This kind of indicating right here can sometimes take a little bit longer to do. And adding the camera, adds another little element there, because I'm trying to share this with our audience and with hopes that they're picking up on what we're doing here, but also want to get the job done at the same time. So I'm looking for an average there. So right there, it looks like about +6. And if we go 180 degrees, somewhere around there, it's about the same thing. It looks like it's on +6. Now I'm going to run back to this jaw here and check these two. So that one's, let's just say -3. And that one looks like it's about -4. So that's telling me that our face looks like it's running close enough for what we're needing to do. I just want to make a face cut across there that's going to flatten that out so that when we set this down on our fixture, we have a nice flat surface there to reference on. And before we do any more work, I'm going to go ahead and recheck these jaws and make sure that they are tight enough. I don't want the plate moving once we start turning this OD. It's just we're not truing up to the thousandths of an inch. This isn't a big deal if it moves one way or the other. Those jaws are slowly kind of digging into that bore there, creating a nice hold for whenever we do our turning. That feels pretty good to me. Visually, it looks like it's running nice. Here's a look at the back side of our sample, and we got Dad's vernier calipers sitting out right here. Anybody still using verniers? I think jobs like this is where these type of calipers really shine. It's just more, to me, it's more convenient the way you hold these and use them versus a regular dial caliper when you got to stretch out such a large diameter like that. Unless you're using a dial or a digital caliper that doesn't have the extension bolted to the back for doing depth measurements, is if you can get one that's set up for just doing these kind of dimensions, I think that's better. I've got a photo right here of our sample piece, and this is where I had originally measured these, and we wrote down the finished measurements using the vernier calipers. So we have an OD of 20.5 inches, and all we're going to focus on right now is the OD and just making a face cut across the back. So we'll go over there with our verniers and take a measurement and see about what the OD of our plasma cut disc is. All right, so let's just make sure we're not on that one really bad spot. Let's just get a quick measurement here and see. I'm not worried about doing the fine adjustment on this. I just want to get a quick measurements there. So it looks like we're 21 and 150 thousandths. So we've got approximately 650 thousandths to turn off the OD. So that should be plenty of metal to clean up these low and high spots on there. That's why getting that average on that front side should be really good on getting this all cleaned up. So I think we're ready to start making some chips now. Let's fire it up and see what it looks like spinning. Yeah, looking pretty good. For our turning, I'm going to use this 2-inch diameter boring bar with a CNMG insert. I actually have an insert on there designed for aluminum. I'm hoping that it works pretty good, so we're just going to give it a try and see what kind of chip we can get out of it. Trying to figure out a good turning speed right here. I've got it set at 91 RPM, so let's see what kind of surface speed that's going to be. So we'll go 0.262 time. I'm just going to call this 21 on the OD times your RPM. So 500 surface feet a minute is what we're running right there at 91 RPM. So that's a good starting point, and then we just got to see how it's going to react. Is it going to try to ring on us? How the chip is going to look, you know, all those good things. So I'm going to set it at I've got it set at 10 thousandths per revolution. So let's give it a go. Let's see what we can do. Make sure everything's clear and good, and it is. Just going to bring this in until it touches. So this is 150 thousandths on the dial. So 150 off the OD. Oh, got to change feed direction. There we go. Getting a little bit of ringing. Looks like we got the high spot off. Go back and take another 150. Let's go ahead and repeat that. So now we actually have it kind of established, mostly round. You see there's still a few little low spots in there. But what we'll do is go ahead and get another rough measurement on it, see what our diameter is. We're still about exactly where we started at. So this is measuring 21 inches, 100 and about 12 thousandths. So we still really haven't taken the diameter down much because we had so many high spots on there. So we just got to keep whittling it down. We may try a little bit of lubrication on this. I got some WD-40, which works pretty good on aluminum. So we may try a little bit of that and see how it reacts and see if it'll help shear that aluminum just a little bit better. Still taking the same amount, 150. That's some WD-40. Let's see what happens here. Once we get down to our finishes, we'll make sure that we leave a nice finish on that OD right there. It's pretty terry right now. It seems like it's kind of soft and gummy. So we should be just under 21 inches now, and we are. Yep, so it's about 950, 20 inch 950. So about 450 thousandths still to go. So the problem that I got with the WD-40 is that it's just smoking quite heavily. So I believe I'm going to go ahead and mix me up some mist coolant, and we'll use my little mister over here. We got that Noga, got a hot chip there. We'll put that Noga coolant spray down here, and hopefully that'll help lubricate it and make a little bit nicer looking finish there. All right, we've got our Noga Mini Cool set up with our mist. Let's see what that does. I'm also going to back down on the cut. We're just going to take 100 thousandths. We got about 300 to go. Now it doesn't want to break a chip. Look at that. There we go. Stand back, whipping around on you. This is where you just stop it, stand out of the way and stop it. I'm going to go get some pliers and pull that chip off. That's the one that's trying to cut us right there. $200 thousandths. All right, so we're going to be down to our last 100. We'll get a better finish on that by slowing our feed rate down, probably down to 5 thousandths per rev, and sneak up on that size. The tolerance on this, as I said, is very loose, but we want to try to keep these guys consistent as we can. So my target, my personal target, is try to hit all these guys plus or minus 2.5 thousandths, with my 21.5 being my target. So I don't mind going under 5 thousandths, but I don't want to take it anywhere over 20.5, because I want these guys to drop down in our fixture, and we're going to mill those 20.5, and I'd like to have this OD make the plate center up on that fixture. All right, so here's where we'll go ahead and, I mean, you can still do it like this, and we've got 100, looks like about 103 thousandths to come down to the size. So at this point is where we'll go ahead and lock this thumb screw here, and then hold the other side with my left hand. And what I do, this distance right here, which I believe is, I don't remember what that is, about a 1/4 inch, I try to line up the face of the part with that shoulder right there. So I'm going to hold it with my left hand and then put my fingers underneath it to kind of keep it from falling. And now we're going to take this side and rock it up and down. Too far. Rock it up and down until you touch it. So there we are, touching. A little bit too tight, but that's good enough. So 603 thousandths right there. So we've got approximately 103 to come off the OD. We'll take half of that right now and see what kind of finish we're going to get. Actually, we're going to take another rough cut, 50 thou, and then we can probably split it into 2 finishing passes about at 25 thousandths. Oh. See, there it is. It built up on it, which is what you don't want. And you see the mister just keeps, it's like it keeps clogging up every time I go to turn this thing. Built up on it, and that is a problem right there. Definitely don't want that. I'm going to slow our feed down. I'm going to see what happens there. Cut it down by half. May have to go to a different insert. Come on, coolant. Just ain't wanting to work today. So that's a 5 thousandths per rev feed. It seems to be working pretty good. Want to where it just touches. That's actually a little bit too tight. So back off. You want it where really just the weight of the caliper makes it slide past that touch. Feels pretty good right about there. 20 inches, 552. 52 thousandths. So let's just take 25. See what it's going to look like right there. I don't really want to spin it any faster because we are getting some ringing out here. Since it's only, touching here, it's trying to vibrate a little bit. So I think if we go any faster, it's just going to make that worse. I'm gonna have to take that thing apart or something. It just won't stay where I set it at. We got that little bit of ringing in there, but our finish doesn't look too bad. I know that when we work on the next one, I may play around with a different insert and just experiment and see if we can get a better chip, a better result, and a better finish from a different insert there. I'm actually going to drop it a gear. We're going to go from 91 down to 77. Not really concerned about what the surface speed is. This is where, as a manual machinist, you have to listen to the machines and let it talk to you and feel it out. Just ever so slight of a touch right there. All right, so we are 25, there's 25, there's 30, 28 thousandths. 28. So we're gonna dial in 28, and that should put us dead on 20.5. All right, we're dialed in our 14 on our dial right there, which should be 28. Let's go for it. Put my earplugs in. I have to wear these things. This kind of work here, it just kills my eardrums. All right. 77 RPM. Let's get our mist going. All right, I don't want to drag the surface, so we're gonna back the tool away. Hopefully that's gonna be our finish right there. Just touching. Just have to feel that. All right. I hit 20 inches, 498 thousandths. So I finished 2 under my target, which I bumped around on this dial when I dialed it in. It should have been 14 on the dial indicator, and I kind of bumped it around until it went about a half a thousandths. With the hopes that it might go about a thousandths under, and it did, but it actually went 2 thousandths under, so that's good. So that's within my 5 thousandths tolerance that I'm setting for myself. So we're good on our OD. I'm gonna have to set up another tool, probably set up another boring bar with a tool bit, so we can go ahead and chamfer these corners, and then we got to set up a facing tool so we can clean that face up. Okay, here's our chamfer setup using a 1.5 inch diameter Aloris boring bar. This is a double inlet style, so you've got a 45 and a 90. I've already got this tool bit ground used for chamfering. And so this is that split bushing that I made, 2.5 on the OD. You can see the split on the inside. It just clamps it down using the D1H holder there. And I'm gonna go ahead and chamfer the front side, but I wanna remove this outside because it's just bugging me. I don't want it to be there, but we can come back and chamfer that again after we get our face. Just breaking that edge off there. So you gotta stand back, because that edge is going to come around and try to hit you. Try not to let it dwell because it'll probably try to ring on you. Got a little bit more there. There we go. All right, now we can work on our face. We're gonna give this insert a try. So this is a Walter insert. I just opened this pack. I haven't used these before, but they are rated for aluminum with a surface speed between 1800 and 3000, which we're not gonna be running that fast because we'll deal with chatter. But this is a good looking insert right there. It's got that nice positive geometry molded into it. It's got a coating on there that looks like it might make a nice slick surface. So we'll just give it a try. I'm going to put it in this holder right here, and we'll probably do something like this, go across the face in that manner. All right, let's give this a go. Still got it in that 77 RPM range. Set a dial indicator and just take 10 thou at a time until we, looks like it's cleaning it up. And let me get some, I'm going to spray some WD on this face. A little bit of lubricant. I can't hear you, man. What?
Joe said come grab whatever you got made up.
Okay. Those standoffs?
Little run dudes?
Yeah, little standoffs. I had a little interruption there. I was expecting a truck driver and he had showed up. So we got that taken care of. Need to go ahead and start back on our cuts. There's definitely a high spot out there. I'm gonna take 5. I'm just curious if that's going to clean this up or if we're going to have to take a little bit more. If we got any low spots, I'm going to come back and hit it again. I'd really like to get this in one pass if I can. Still got a little bit of a low spot there. Right there. Try it again. I think we're going to roll that and see if that cleaned it up. So that's 25 thousandths. Hearing a little bit of ringing in it. Let's see if it'll kind of maintain where it's at. So I don't know if I had mentioned this, but the overall thickness isn't a big issue. Like I said, we've got some loose tolerances on here. To go from 1-inch plate up to even, you know, 1 1/8 or 1 1/4 was a pretty big jump in material cost when the overall thickness doesn't really matter. You know, so if we're, you know, 50 or 60 thousandths thinner on the finish, you know, from 1 inch, it doesn't matter. It really doesn't matter. As long as we make our counterbore right, it'll be all good to go. This side right here that we're facing is going to be sitting down onto the ground, so it doesn't even really matter, you know, but we're making a nice finished part that the customer will have in their hands, and then what they do with it is that's up to them. So what I decided to do was just go ahead and finish that cut, and I'm going to measure what that deepest pocket is. And then we'll take one more cut and that should clean it completely up there. On this pacemaker, you got to be mindful of what you set up here. I crushed one of my favorite classic Eagle oilers. It was right here. Actually, I'm sorry, it was like that. And it got crushed right between. This is the bolt that tightens up the clamp for the carriage there. And you can see it just crushed it. I really hate that because this was such a nice Eagle oiler. But we can still use this guy right here, save it for a part, put it in my box. I got a bunch of these that I've collected over the years, and this still works. It's just won't sit very flat now. I hate that. All right, so there's our face. You can see we've got it bumped fairly true. It looks pretty well even all the way across there. I'm gonna run an indicator on this face and see what that low spot is, and hopefully we'll get that cleaned up on the next pass. All right, we got our dial indicator set up here. And I'm sweeping, just getting in here where we did touch it. Got it set to a 0. That side looks like 3 thou. That looks like 4 thousandths right there. So that's probably more towards 5 or 6 right there at the very end of it. So I gotta figure out what I want to take here. I'm trying to keep it at a minimum, but I want to clean it up at one pass. So we may take like 6 thousandths. I think we might try 6 and see if that'll work. I'm gonna go back with my Noga Mini Cool on this one. So I've dialed in 7 thousandths. That's taking 32 thousandths, which equals a 32nd of an inch. Just kind of make it even right there. I'm hoping that the others are gonna be as consistent and we can take the same amount. That's high gear. We don't want that. That's too fast. Let's go to intermediate range. Trying to chatter on us. I'm gonna see if I can go at a little bit higher gear here. Just gotta be quick about it. Set a 0 here in case I do need to go back into the face. I think that turned out pretty. Taking a little bit longer than I was hoping it would. That's the kind of stuff you get into on those large diameters. especially when you can't chuck it on the outside like that. I think there is nothing wrong with that finish on there. It looks perfectly suitable for something that's going to sit against the ground. All right, so all we need to do is just go ahead and put another chamfer here on this side, and this side's going to be finished up. All we got to do is just break that edge. There's really not much of a chamfer on the original piece. Just want to break it, and I'm running it slow so we don't have any chatter there. That's really all it needs right there. I wasn't going to show this, but what the hell. I'm using some Scotch-Brite for aluminum, and I'm just trying to brighten the surface a little bit. Brighten up the finish on it. It's looking good. Well, I gotta say the outcome isn't bad at all. Once you hit a little Scotch-Brite, it really does bring out the finish that tool puts in there. Cleans all the smuts off the surface, the imperfections from the coolant. And I think it looks pretty darn good there. So that's 1 down, 7 to go on our lathe work. I'm gonna do this right here. I'm gonna repeat this 7 times. Hopefully I'll get a little bit more efficient once we get a couple more in there, and I can kind of get through these. Now that I've got all of my setups, my feeds and everything figured out, now I can kind of get through these a little bit faster. So I'm going to get some video here and there kind of showing what's going on, but otherwise we're going to be repeating what we did right here 7 more times. We're set up on plate number 2. Got a little bit better setup here with our Noga Cool. We're just going in the back of the bar there because this is a through coolant pouring bar, and I've swapped it out to that new Walter insert that we used on the face on the last one. Let's see what happens there. All I did was just knock the high spot off. There's another 150. So far, it looks like it's a better chip. That did better than that other insert. We may have a better cutter going on right there. We're just going to keep it going. I got to get a measurement, see where I'm at now. we just finished disc number 2. This one actually only took me half the time as the first one, but I wanted to show you this. This is the first time I'm actually measuring the thickness. I know that we went with 1-inch nominal thickness aluminum right here, and I faced off 32 thousandths on this one, just like the first one there. And when we measure this with the calipers, that is measuring 989 right there. And I went over to the other one and measured the one that we already faced, and it was measuring 991. So we're winning a couple thousandths, but the material is actually thicker than 1 inch to begin with. That's just the first time that I measured what it was. So that makes me feel even better that we're still really, really close to our 1 inch nominal thickness there on our material. So number 2 down, I'm gonna keep rolling, take this thing out and see if I can get a couple more done today. We're running double duty right now. We got the Miltronics going as well. So we're making money while we're making money. All right, let's get this cut going. I'll show you what we're doing. Well, that was a little far away. Let's get it closer. There we go. Building some more of these guys right here for the welding shop. They need a batch of these, so that's what I'm working on. Got this going while we're listening to this noisy sucker right here. I started on this guy and I had forgot that I had it down in my finish feed right there, and I forgot to switch it over to our 10 thou per rev. 550, that's there. Come on, fart it off. I was trying to get this before we... All right. All right, so that's what we're working on right now. Going to continue roughing in, or actually finishing this OD on these plates. Still got a few more of these to do. And I got a small batch of these standoffs here that we're going to continue to make. Got everything dialed in finally. Looking pretty good. All they do is they drop these into a 1/4 inch thick steel plate. They get a fillet weld all the way around it, and then the whole weldment then gets bolted onto the machine over on the airport. So the other fix, I believe, worked pretty good. So they wanted to replace all of them. There's several of them there. They want to go ahead and replace all of them with that new design. So we're going to get these guys. I'm still not rigid tapping in here. I believe we have it figured out, but I just don't want to break another tap. So it's easy enough to go from here over to the flex arm and power tap it very quickly and efficiently, and then these guys are done. And all we do with this little burr on the back side of that, I'm just going to go hit that on the side of my pedestal grinder wheel just to knock that little burr off and get rid of that. So anyway, thought I would share what we're up to. This is pretty cool. It's the first time I've done this in this shop, is running my Miltronic CNC lathe, and we're running the old school American Pacemaker at the same time. All right, one more done. We got 3 more to do. I feel like I've got our feeds and speeds dialed in nicely. I got a nice little system getting these guys machined. So it's taken me approximately 30 minutes to turn the OD, face it, and chamfer it. All right, we got 1 more done. We have 3 more to do. I feel like I have finally got the feeds and speeds dialed in nicely, getting a good finish on there. And it's taken me approximately 35 to 40 minutes to get one set up, get it indicated, and then turn it, face it, and chamfer it, and get it out of the machine. So not too bad. All right. So I've got this old roll of plastic coated paper that was my dad's, and man, we've had this thing, I don't know how long we've had that roll. I remember having this when I was a teenager at the house. It came from a customer. We used to do some work for a company called Plastic Coated Papers that were here in town. Honestly, I don't even know if they're still in business anymore. So anyway, well, we don't need it here because I'm putting face to face and then back to back. So I'm just kind of doing these guys like this. I just want to protect that machine face on there. So we'll put the paper on there in between this one and the next one. So there's our last 3. Everything's working pretty good. It's rolling along nicely. Currently on disc number 8. This will be the last one. I always go the wrong way right there. That's because I'm holding the camera. So looking forward to seeing this guy done, and that'll finish up the lathe work for all this aluminum here. All right, just about done with these guys. I'm gonna go ahead and get this chamfer done on this last disc. Alrighty guys, this is disc number 8, finished up. We'll go ahead and get her out of here and finish this little segment out. Job's really not done yet because we got a huge mess over here that we got to clean up, which is part of the job. Sometimes one of them other jaws sticks. Yep. Well, there's a nice pretty stack of aluminum discs there. Happy with the way they turned out. American Pacemaker did a fine job on those guys. So now that this part is done, we're going to shift our focus over onto our fixtures. We'll probably, what we're going to end up having is we'll have a separate video on machining these fixtures right here. I don't know if it'll be one video per, or maybe we can get both. I'm actually probably going to do the round fixture there in the Pacemaker, because really all we need to do is just face it. I want to face that and have a register where whenever the ID of this gets machined to its size, I want that to fit on a register on that plate right there. So that should be easy enough, just doing the Pacemaker, and we'll go to the mill to drill a hole pattern in it that we're going to put. This guy right here will all be mill work, and go ahead and show you some new work holding magnets that we got here on the flex. This is a set of 4 earth chain, the ECB 120s. And I've actually already milled the top of them there. They recommend that you mill them whenever you get them. And I had measured them and they were about 4 thousandths difference there. So my plan is to utilize these guys for some of our fixture work. The big square fixture, we can set it up here, mag it down, mill the top of it, flip the thing over, mill it, drill the holes and that kind of stuff. And then we can set the fixture down onto the bed rails at that point. So this is a really cool work holding fixturing system that I've never been able to use until now. So really excited about that. It's going to come in handy for a lot of plate work over here on the flex. I still have a big fixture plate here. This is a piece of 1 1/4 that I want to machine for the Tombstone City plate. So this is another one that we'll be able to use our magnets for, and any other future work coming in where we have some plate work that we can hold down using the magnets there. So that's going to wrap up this video, guys. We got all the lathe work done minus the fixture. That's what I'm going to start on there. So we'll have some separate videos showing the machining of our fixtures. And of course, once we get into the mill and start finishing all of the inside work that's got to be done to these discs right there. I hope you guys enjoyed watching. Thank you guys for the support. Thank you for subscribing and liking the video. And I hope to see you here on the next project.